system that actually will start taking action, will start doing, still advise, but actually getting in front, making changes, retiming signals, all those kinds of things. So a grant did come out under the TMDD program. We applied for it, and we were awarded one of the 10 awards at that time. It was the Federal Highway put up $5 million. We put up $5 million as a match, and our Secretary of Transportation and everybody in the department strongly supported that. So that's the funding that adds on to our existing funding with the program we already have. The hardest thing is for me to move my mouse. All right, we have basically 3 deployment areas, as you can see on the screen. The northern part of the state of Delaware is where the interstate system is, 95, and that's our urban area. That's where we initially started developing, implementing AI, the first phase of this. It is also, we replace controllers and all those kinds of things. So that is the area we'll be evaluating the urban side of the application of AI. In the middle box is the center of the state. Our Transportation Management Center is located just north of Dover near Smyrna, and sort of almost in the center of that box. That's the area where we are already, that's going to be our test area, because we're here, and so we'll be driving through and using the system. This is the same corridor where we have implemented the OBUs for the Connected Vehicle Program, and have signals operating with the RSUs. And we have several state vehicles equipped with onboard units. So that's our test area for testing new technology. In the state capital is Dover in the center. The bottom box is the, again, you can tell we're a beach state. In the summertime, we get a whole lot of people going to our beaches. So consider that rural plus, but it has a ton of different traffic demands when it's summertime. And so that area is the other area that we are putting in all of these areas. We're doing changing all the controllers. We're equipped to a certain level to SPAT stuff, but a lot of our AI work initially will go into these 3 areas. Again, we divide this project up in all of our projects up. We have an advanced traveler information system, everything that everybody's doing. We actually are the only, I believe, the only transportation agency in the United States that owns a primary licensed radio station. And we've expanded that coverage of that station statewide. But all the other things from apps to everything else, that's part of how we provide information out. Infrastructure, we're going to continue to deploy everything else, the cameras and so forth. And any new technology, especially in those areas I showed, that would be part of integrating with the AI. And then the whole operations 24 hours a day, 7 days a week of the things we do, which we're responsible for. Anything that impacts the state's transportation system is managed from and through our Transportation Management Center. Our expected outcomes is, again, a truly predictive and adaptive self-monitoring transportation management system. And that includes transit, which I forgot to mention. Our transit system is integrated to our system already. The automated operation and enhanced decision-making. We all depend on real-time and accurate data to make the decisions we have to make for the daily normal stuff, but we're constantly having incidents and events and so forth. Reduced incident detection time, which is critical, and the monitoring of the connected and automated vehicle operations. And the system learns. It's already learning in the area that we have outfitted with some, and it will get smarter as this thing goes along, and we'll see how that helps us as we move forward. Without going through all of these things, you name it, we're probably connected to it, have sensors. We also have you can see there as a side note, the weather side, where we have the lowest mean elevation of any state in the United States. And Delaware is sinking at the same time the water is rising. So we have integrated our hydrology systems in cooperation with USGS and others into our system and into our program. It will be part of the AI. High-resolution data from our controllers and all the other information. We are a partner with Waze and so forth. All of that goes into our system, and then the AI will process that. We're jokingly saying we're building Gene, me in a box, because of how a transportation management system should operate and what it does with the transportation system. The current status is the program started with the grant in October of 2019. We're working on the system engineering. You know, it's always hard to get the engine, the machine going. We're starting to roll with that. Computer hardware has to be ordered. We're really enhancing our computer network and so forth. And current software capabilities, it says here on 5 minutes, but we're really going to be a lot more data, but we're going to process at the minute level for most of this stuff. 24-hour continuous monitoring and automatic data visualization between cameras, machine vision, and those kinds of things. And then traffic flow prediction. That's a big part of this. And then if something happens, the stuff you see in the photographs is the northern area that is already had controllers changed. The software is already identifying problems and starting to advise of those problems. The next, as we enhance that, I want to stress, we want it to start taking, adjusting signals, rerouting traffic, and so forth with what it is monitoring. And that's all I have. And, I'm open to any questions or however we're handling it.
Gene, thank you. I know that when you added your 23 and 27 years, it adds up to about 50 years of experience in traffic and transportation management. So I'm not surprised that you're at the forefront of this. A couple questions for you. Within the systems engineering process, where are you guys actually at? Do you have a ConOps that's been developed, and are you in the design, the high level or detailed level design phase yet of the project?
That's part of what we're bringing on, and it was on the slide and I forgot to mention it, but we are through our consultants, we have to do the system design, the architecture, and so forth. Plus, we have to do an evaluation part of that. All of that is in the process of being developed right now.
So as you get through this step by step through the grant, are you able to then share those documents with other members?
Sure.
Like the CONOPS in particular?
That's no problem.
Okay.
I'm the worst record keeper. If you looked in my office I'm in right now. But yes, I have consultant staff that takes care of that.
Okay. And another question, because I see some folks are typing, so another question I have is, when you talk about the automated decision making from a traffic management center, do you envision a change in workforce position type if there is automated decision making involved with this, or how do you envision the workforce changing with the AI applications?
Denise, I'm glad you brought it up. Usually I put this plug in whenever I speak, and anything as I travel around is we do not have the pool of people in the United States to support what I'm talking about at all levels. I also sit on a committee under AASHTO that's looking at what a transportation agency should be for the future, and it has to change. We don't have time to go into that now, but I can't hire the people that would have the skill sets for this because we're the government side. But really stressing to anybody that's from academia or the federal side, we really need to create programs that now create the next transportation professional, technicians and engineers and planners and so forth, that better understand transportation management and the application of these technologies.
Okay. Gene, there is one question in the chat box right now that is asking if the ITS architecture had a role in the project when you did the grant.
Who's looking at this? Well, you heard how many years I started this stuff before anybody did that kind of thing. We have that as part of the program, but we have, because of the strategic plan and a vision, I break this down into, you have to have a vision, you have to have a plan, you have to do the normal engineering stuff, the design. Because you're dealing with technology, you have an implementation phase that has to be inserted in there, and then you have an operations side, you have a maintenance side, and I always add in you have a training part there. So taking that and continuously doing that is how you come up with a vision for these things, and then eventually, and then implement it, and then you have an operating system. We've built one heck of a system here, and that's the process that we follow.
Okay. All right, Gene, thank you. I'm sure that as we move on, there may be some more questions, but thank you for the, I think is this the only AI project on the corridor right now that you know of before we move on?
At this level, yeah, there's not much else in the country.
Okay.
Right.
Yeah. Okay.
Thank you.
All righty. Well, thank you. All right. We're going to move next, and let me. Before we start, though, I did not have the actual bio information in front of me, and that was my bad. And so before we start, I do want to go back and touch base a little bit about Nick and Joe, who have been so willing to do this webinar, and I'm very appreciative of it. But Nick is from Caltrans, has done more than just to be the TSMO, I suppose, statewide lead, and working with the connected program in Caltrans. He's also worked, I think, 20 years with Caltrans. He's been with their District 3, their Director's Office, Transportation Commission, and the Divisions of Transportation Planning. So being as big of a state as this, he's done a lot. And he also, which I found interesting, is an adjunct professor of transportation system planning and at San Jose State University. So he has a great background in this. And So I'm looking forward to his discussion. Joe, in addition, because they're going to trade off as a duo here, he's worked at Berkeley for about 11 years and managing as I mentioned, the Connected Corridors program, the ICM program. He works a lot with computers. New ideas at the university. I'm sure you know universities are known for being these think tanks. Prior to joining PATH, though, he was a manager and a director at a number of software companies in the Bay Area, so he does have that deep background. So with that being said, to give them a better intro, I'm going to turn it over to Nick and Joe now. All righty. Thank you.
Okay, thank you. This is Nick Compin from Caltrans, and we're very happy to be here and provide this presentation information for you today. Joe Butler and I have been working together for about 11 years, I guess, or 10 years or something on these types of things. And so we want to talk to you a little bit today, and I'll give you a quick little overview. We're going to talk about our Connected Corridors program a little bit. We'll explain about our pilot on the 210 in Pasadena. Then Joe will talk a little bit about UC Berkeley PATH's role in this, which they've been a partner from before the beginning with us on this. And primarily he's going to talk about the architecture of our data hub, the C2C interfaces, the decision support system, the fairly technical pieces. And then I'll come back and talk a little bit about the status and the schedule that we're under, and then give you an idea of what we're looking at, not just for today and tomorrow, but 5 years, 10 years down the road, and how we're implementing that. And then finally, talk a little bit about the open source portion of our data hub, and then kind of put out there that we're looking at a pooled fund type arrangement, and kind of gauge interest in something like that. So first thing I want to do is I want to talk about is when we think about integrated corridor management here at Caltrans, we think about the picture you have in front of you right now. This is from the I-210 several years ago. As you can see, there was a big rig that ran through the barrier. It ended up on the gold line and melted the tracks. And so, non-recurrent event that you have to manage immediately. And so what happens on the left-hand side, you got the California Highway Patrol that come out and they close the facility, and of course you see the backup on the left, and then on the right, that's what happens to everybody else who's waiting to go through. It just backs up for miles and miles, to be honest. And that is a challenge and kind of I would say a problem. But with that being said, I see an opportunity. And the opportunity that I see is where these gold arrows point. If you can see blacktop on your network, that means you're not managing it to its fullest potential. And so I'm seeing opportunities to do integrated corridor management, implement it, and use those facilities to alleviate that congestion that's on the main highway. This happens to be, we look at it as reversible also. If there was congestion on the local arterials, we could absolutely use our ITS elements and equipment to redirect that traffic so they could get back to the freeway and on their way. So it's a true partnership. So with that in mind, we started thinking about integrated corridor management and how do we do it. And so we went to our local think tank, if you will, our partners at UC Berkeley PATH. And we also enlisted consultants like Aimson, Capsch, Parsons, and Telegra, and we said, we want to tackle this. How about we all do it together? And so basically our main focus is how do we get more out of the transportation network that we have. We have a couple of different major philosophies, things that we go by, etc. Many of you probably have a pyramid that kind of looks like this, or at least something that points your way forward, where you have system monitoring and evaluation on the bottom end with maintenance and preservation. As you move up, you get, add more ITS, you end up with operational improvements. And then finally, after you've done all of that to your system, then you look towards system completion and expansion. We call this our mobility pyramid. On the right, we created, we call it the TSMO umbrella, because TSMO to us is an overarching philosophy of managing and operating our system, and any activities that you take to do so fall under that umbrella outside of actually adding capacity. And so our Connected Corridors program that I'm talking about today is just one of many strategies that we take to implement and conduct TSMO. So for our program and pilot, we use the term Connected Corridors as kind of branding for our effort in order to highlight our program and to differentiate our effort from FHWA and others. We found that, you know, branding, highlighting, creating a name for what you're doing is very useful, and if you don't get silly, it can be very useful. So our state program focuses on a lot of different things. You know, of course, ICM to corridors in California. We wanted to grow our DOT's leadership in corridor transportation management. We want to be able to showcase new technologies and processes. One of the reasons we brought on UC Berkeley, of course, to get that, you know, that what's next, the new things, and then deliver ICM implementation on the 210 in Los Angeles. You have to do it once to show you can do it and do it well, and then you can follow up with your program. We also looked at renewing or establishing standards, statewide standards. That can be a challenge for a DOT as large as we are, and so we wanted to provide something that everybody could really use, and the standards would be attached. And that's a different way of thinking about it, rather than just saying follow the standards and everybody says, you know, why. And then providing a solution that's affordable, replicable, and scalable. So we entered into this program from its inception looking at how do we do it statewide in all of our urban districts, which we have 9 of those, and you know, making sure that it was available to all and could be used statewide. And then finally, lowering the barriers and to ICM adoption, operation, and maintenance. You want to make sure that you make it easier to fund and estimate the cost for it. We also did a great deal of work in looking at workforce skills, several different contracts to look at the knowledge, skills, and abilities, or KSAs, of our staff and the folks that are coming through universities, and determining how we can help to ensure that we have people to fill the positions that we need. And then the technical complexity and risk, we want to lower that so that for each new ICM implementation, it's far easier to get in and get started as quickly as possible. So why a single statewide system? Well, direction from our program management here, I'm in the Division of Traffic Operations at Caltrans at headquarters. You want to control costs, of course, through economies of scale. You want to uniform data across the state, and that way you can do performance measurement and performance management. Again, replicable, scalable, affordable, and maintainable. Those are the prime directives, if you will, that we got when we started this program, all within the idea that you have to design it so that it will meet current and future needs of your pilot, but also the future needs of your local partners across the state. So it's a pretty tall order, but we've kept it in mind, and I think we're doing a good job. So why UC Berkeley Path, and what are we doing working with them? Well, we wanted to make sure that we'd have system engineering documents and templates for folks to use, good examples, actually not just good, excellent examples, I'm going to say. We wanted to make sure that we did have an eye towards workforce skills and training for our organization, and that's where universities come in that training and getting those folks ready for what you need them to do. We also wanted to make sure that we worked with the consultants who are involved in California and elsewhere, because UC Path is a research institution. They're not going to, they're not in the business of supporting the technology forever. And so we really thought, and we still do, that we need our consultants to understand what we've done so that they can help us, the DOT, support it. And then we also looked at a cloud-based reference implementation architecture with a real focus on data quality. Everybody says they understand data quality. They really don't. A lot of times they understand ITS equipment functionality, things like that, but data is something that most, at least many DOTs and a lot of folks that we work with are not really ready to handle, and they aren't really looking at it closely enough. So that's part of what we wanted to do there too. And then the cloud-based implementation allows for replicability, scalability, and allows us to have a data hub and DSS, or decision support system, that is in the cloud and can be easily replicated and spread throughout the country and even the nation. So again, working with PATH and making sure that we have good quality documents and system engineering documents. We documented human and organizational requirements, because a lot of times people think about technological. We wanted to make sure that we talked about the human and organizational requirements that we have. We've created example MOUs, charters. We have data quality standards that we've documented. We have a very advanced model, which Joe will refer to later, but we wanted to make sure that there was guidance on how to do that. And then the idea of how do you organize and tailor this for each ICM effort that you have. So we've not only done all of that, we've made it publicly available. This is a website that you can go to, and you can download any of the documents that we've created. Many of them are I would say they are in excess of what a lot of our fellow partner consultants would do, and that's good, because now you can basically go into them, you can look at what we've done, you can select what you want, you can cut what you don't, and you're pretty much quite a ways along the way. If you're looking at your system engineering or concept of operations documents, you can use those as templates, or at least examples to go from. So with that, this is just a high-level look at what our connected corridor system looks like. And the subcomponents, where the green pieces are data in and out. The data hub itself is in red. Decision support system is also internal. And then we've got a corridor management system, which is a COTS implementation, and is left to our districts or whomever to determine what they want to do. And I'm going to turn it over to Joe Butler now from PATH, and he's going to discuss this in more detail.
All right, everybody. Well, thank you, Nick, and everyone who is listening. It's pretty exciting to be talking to the entire country here. So a little bit about Caltrans and UC Berkeley. So everyone knows Caltrans is a pretty large organization. It supports 21 million licensed drivers, and I don't know how many unlicensed ones, but probably quite a few. There's a lot of congestion in California, and it's really hard to go on building roads forever. So as Nick was saying, Caltrans is focusing quite a bit on transportation system management and operations. And so when Caltrans started to talk to the university about the best way to really do TSMO's activities, they came to the Institute of Transportation Studies at UC Berkeley. Now that is an organization that was founded in 1948 by the California legislature to really make sure that California could grow economically and really after the war, fill in a lot of the infrastructure deficits that had been built up. It's a training organization. We have about 100 graduate students at any time there, both master's and PhD level students. And PATH has led the way with a number of different interesting technologies. We did the first automated driving demonstration, for example, so long ago. first loop detection system. It's called PIMS. And really, PATH is focused on moving the ideas from a lot of the research into realization. And just within Connected Corridors, in order to do that, we have about 20 professional staff. So we are not a research organization in the standard sense. We are an innovation transition organization, I would call us. And we have the professional software engineers, modelers, outreach personnel in order to make this happen. Excuse me. So what's our mission? Our mission really is to make this picture work all across California. There's various cities, there's various stakeholders, CHP, all sorts of transit agencies. How do we bring everyone together in a way that they can look at the state of the roadway and make really good decisions? We're trying to put together a decision support system which will assist everyone in making decisions everywhere from the planning level down to what should happen immediately on the roadway based upon an incident. So the university looked at this as this was really a mission to develop a holistic vision for 21st century traffic management. Given that we have new computers, we have the internet, we have amazing amounts of processing, we have new AI and machine learning algorithms, how do we bring all of these things together with connected vehicles and intelligent devices and really better manage our transportation system? Then how do we implement this? Technology, education, and legislation. And all three are essential. Technology that can't be operated appropriately is not useful. Education is very important to make sure that the new generations of traffic engineers are also integrated with data scientists and software engineers to really run these new type of systems. And I really give a call out to, Denise and Jean for mentioning the workforce issues. The university is really focused on trying to build the next generation of individuals that can work on transportation management. And of course, legislation. For example, for the university worked with the state of California to make sure that there was actually a data scientist position available so Caltrans could go forward and hire one. So again, there's a lot of work goes into making sure that cultural changes can occur. When Caltrans came to us, they actually said, look, we're going to ask you to help us make some cultural changes. This is going to be hard. It's going to require a lot of work, and push forward and help them. And the universities are in unique positions to do that. As we went back to the AASHTO Center of Excellence to discuss the issues of workforce management, and generally the notion was that the DOTs probably should be working with the universities in order to make this happen. So once we implement the vision we have, we want to pilot this implementation on, in this case, the I-210, which is in Los Angeles. Many of you are probably familiar with the Rose Bowl. That's where is in Pasadena, and Pasadena is the largest city in this corridor we're working on. So once we open source this, we're now working with various consultants to make sure that they understand this, because the consultants have some of the same challenges that the DOTs have. They're they don't have all of the education needed to always do software engineering work or data analytics work. So our goal is to raise everyone's boat. So put this together, open source it, and then fan it out across California and the nation. And we say open source, this is going to be a pure open source. Anyone who wants to use this can use it. We're not going to limit it to, only government organizations or that sort of thing. Okay, so what are our overall goals? Well, the very first thing is reduce costs. Implementing integrated corridor management can be expensive, and so it needs to become less expensive. How do we deal with this immediate lack of IT expertise in terms of data and software? How do we make a system that can be run by sort of today's and the next close generation of traffic engineers. How do you build systems to handle big data? Really, big data has barely showed up on the horizon, because once connected vehicles start really sending their data in, people are going to find out what really big data is, and it's huge. The current systems aren't really set up for AI and machine learning. It requires a lot of parallel processing to do AI and machine learning. And so that's the sort of thing you're not going to be running in a data center somewhere. You're going to need to run it in the cloud, where you can scale up and scale down the processors that you need. In my travels, I note that really operating integrated systems where one central system controls, say, multiple traffic signals in multiple different cities and jurisdictions, that just doesn't happen too often right now. And how do you do that? And so we needed to understand how to overcome that challenge, and then really get us off IT servers. Over Christmas, we have a very important feed that sends all of the data from the freeways into our system. That system went down at Christmas. And I just want to say that there didn't seem to be a great rush of individuals in the DOT at Christmas to run in and fix it, nor did there seem to be a great rush the day after Christmas. And so we need to build systems that are self-healing and or can be accessed very easily from different locations, so that we really can run 24/7, which is needed for good traffic management. The other side of it is purchasing. Oftentimes, the ability to purchase new equipment within DOTs, it's a long cycle. It's very, very nice if all you have to do to scale up is just in the cloud, you just toss in another processor, and it takes no time at all. And so that alone reduces, the time it takes to do implementations by a significant amount. Okay, so what are the technical concepts we're using to carry this forward? So the first one is, of course, we mentioned big data, rules, and AI machine learning. We have to make sure that the systems are set up so that can be used. We're trying to bring in the best ideas from Silicon Valley and from academia, and UC Berkeley is well positioned to be able to bring both academia and Silicon Valley together to do this. We're very interested in bringing in data from intelligent devices and really giving data back to intelligent devices. What we find is the more intelligent the devices are, the more they're prone to think they know everything and try to make decisions. You have adaptive traffic signals that really can make really bad decisions during an incident, because they don't know what everything looks like. And so, as with people, and intelligent devices need to be given good information in order to make good decisions. Data is the core of everything, and so we've designed everything in this system around the data hub. And we'll be talking a bit more about that. But the data hub is useless unless you have data standards that get you data that you are sure you know what you're getting and you can measure the quality of. And so the heart of this whole effort, I would say, was the extension of the Traffic Management Data Dictionary standards to permit the really well-defined exchange of information, and then the funding of the building of a number of interfaces to existing traffic systems to make sure that this data can be passed in that way. Very interested in affordability, scalability, configurability. We just have to drive down the costs of implementation from any number of angles, and again, raise all the boats. The university doesn't make money. The university's payback is really in raising standards in society and helping society to move forward. And so that's really our goal, raise all the boats, including all the vendors. So, what are our constraints and principles here? Basically, it has to run very quickly in real time and come up with decisions fast enough to make a difference. It has to be extremely secure. You really can't have someone hacking a system that is sitting out there trying to control traffic lights. Scalable. Some districts in California are small, some are very large. Again, if we look across the nation, that is definitely true. You want to be able to scale to the right size or the level of congestion or the number of drivers in your area. Maintainable, flexible, basically a reliable system. So the major system components, as Nick mentioned earlier, are the data sources and the data sinks, the control targets, the green boxes. the TMDD interfaces, very important, and then the data hub, the decision support system, and the corridor management system. And we'll talk about these. So the data hub's job is to receive, process, store, and deliver large amounts of different data types. And that's streaming data, structured data, et cetera, rules-based data, you name it. The decision support system is responsible for understanding the roadway network and helping you decide what is the best traffic control strategies you should be using at this time to manage your network. And that's a broad-based traffic control strategy. It means what communications should we be sending out to whom, what signals should be changing, what sort of overall demand management or mode shift should we be looking at. Then the corridor management system, when Caltrans came to us, we did an initial study and we determined that the data hub and decision support systems that were in existence really needed to be significantly upgraded to new technologies. But the corridor management systems, which are the user interfaces, the workflow engines, they were good. I mean, you could go out and you could deal with CAPS, Parsons or Telegra, and you could really get a nice interface. And so we determined there was no reason for the university to develop those sorts of products. And so we partnered with those companies and to build the interfaces needed in some of the additional workflow components so that they could tie into the core areas where we were bringing new technology and new ideas in there. And so we weren't out to build everything from scratch. If it was there and it worked really well, we wanted to use it. So the design is set up so that there's a clean separation of responsibilities. If you have a particular type of decision support or AI that you'd like to use, as long as you meet these interfaces, you can slide this right in there. And we put a lot of work into that sort of modular implementation. Okay, as I talked about the TMDD interfaces, this is probably the most critical part of the vision. If you can't exchange information effectively and know what you're getting, you cannot run a system. We have looked at different traffic control systems, for example, and they will call the exact same piece of data, different pieces of data the same thing, and then you end up making a decision that's not quite what you would have expected. So we started with TMDD, which is a core approved standard for the exchange of information, and we have expanded that, and we are working with the TMDD folks to get these changes into the standard. For example, you couldn't really express a response plan, i.e., how should I change signals, ramp meters, etc., in TMDD. It wasn't really built in there, and so we're adding that. And it's very important to add that because this vision isn't about us just sending this information to intelligent devices and people. It's about sending the same information, for example, to Google. So Google understands, Waze understands what's going to be happening and can better direct traffic so people don't end up in cul-de-sacs somewhere where they don't want to be. So our goal is to holistically, again, improve the overall transportation system. In terms of these data sources and control targets right now, what we're talking about is really traffic signals, ramp meters, signs, lane closure systems, various ATMS systems, transit, etc. They're really the sources of the data and the actual systems that control the ITS elements. Nick is going to expand on this document when he comes back on to speak. This is the core system for the I-210. It's already being expanded for other areas in California. So this is the way it works. You choose the systems that you have, and in this case, we're working with KITS, Transparity, TransSuite. We know the sign vendor now, but I didn't update the slide. And Caltrans ATMS. They all have C2C interfaces that have been developed and are standardized to provide information. So if you have any of these systems, you can plug this interface in elsewhere in the nation. The data hub then understands how to read this information, and it processes it slightly to make it completely a generic standard internally. So all of the different systems get exactly what they expect, even if there's subtle differences between the systems. So Caltrans will provide a DSS, a data hub, and you can choose the modeling solution you want. We have used AIMSUN. We find them to be a very good microsimulation model. And then The three companies we're working with for the interface and workflow management are CAPS, Parsons, and Telegra. And so, again, they send data out on the same TMD interface, goes back to those same systems to actually affect the network. The overall architecture, probably the single most important decision we made after choosing to use TMDD was that we would work in the cloud. And we chose Amazon Web Services because certainly at that time they were the most secure and scalable and widely used. And it's been a very successful collaboration between Amazon and Caltrans and the university. We use a microservice architecture. I won't go into this anymore, but just what it really means is that all the various components communicate through message queues, so it's really remarkably easy to switch one in and out or to upgrade one without upgrading the rest of the system, which is often what happens in monolithic systems that have been built earlier. That was very hard to do. We're using, we looked around for the best open source software we could find. It turns out for workflow management, Netflix had built one called Conductor. It's excellent, so we're using that. Testing frameworks are very important, so you know when you make a change that things are not going to break. Oftentimes it seems in current systems it can take a long time to do an upgrade, and when it happens it can take a long time before the system works right. We're trying to really address that. Java is a very common language. We use two common databases, Cassandra and Mongo. I'll talk about that in a second. And then, of course, monitoring software. And we've reviewed this architecture with a number of different people, both from the UST and industry, and have been given the thumbs up on it. So the Data Hub, which is the core of the system, has been designed really for a number of things. It's been designed for streaming data, basically high-volume connected vehicle data. The ability to bring this data in high volume at the rate it arrives is non-trivial. And that's why you want to be working in the cloud so you can stream up or stream down, scale up or scale down, based on the time of day, et cetera, the number of vehicles that are sending information. And then there's structured data. For example, signal plans. Signal plans is an example of structured data. Want to be able to bring that data in. And it requires two different types of databases, Cassandra for streaming and Mongo for documents. Again, these are open source databases, and they're really built to work in the cloud. We do a lot of data quality work, which really leads into the machine learning aspects of what we do. It's not easy to determine if data is really good or bad, and that's where we're starting to use some AI and machine learning to give us some hint of that. Our biggest challenge with AI and machine learning right now is catastrophic failure issues that are still sort of plaguing the AI industry, where it works quite well in circumstances where it's been taught, but makes some bad decisions when incidents happen because it hasn't been taught enough on incidents. And so there's a group of, I think, 30 people at the university who are working on that problem right now, along with, as Gene mentioned, computer vision. There's another whole group working on computer vision here, really related to connected vehicles and automated vehicles. And then, so that's the diagram for the Data Hub. It's working pretty well. In terms of decision support, we spent quite a bit of time trying to understand the best way to do a decision support system that could be used by multiple agencies and people with different levels of expertise. And so what we chose was Drools. It's an open source rule system. In the end, even with AI or machine learning, you have to have rules that wrap around it. What you want to do when, what are the limitations, what are the parameters. And so we have a Drools engine, which allows you to enter rules. And we thought a great deal about the user interface for this. And finally, after a lot of discussion, came up with Excel spreadsheets because everybody can use them no matter where you're at. And if your rules become too complicated for Excel, there's something you need to go back and reponder what you're trying to do because it probably isn't implementable very easily. The other really important area is estimation. You really need to know what your corridor looks like or what your roadway looks like before you make a decision. And that doesn't mean just the freeway, that means all the arterials. And so we've put together various algorithms to help us understand what does the corridor look like so we can then make better decisions. That estimation, in our case, feeds into prediction. And we have a prediction model that has 400 signalized intersections that we're working with on that corridor that predicts what happens when we try to run certain response plans. And then out of that comes recommended response plans, which then go to the corridor management system, which is presented to the stakeholders so that they can then approve or disapprove it or automatically approve it if that's what they choose to do. And again, this is all modular, even internal to the decision support system. If you wanted to use a different rules engine, as long as you output stuff in the right format, you can pick and choose. Now, one of the more interesting discussions we've had has been, how do you actually generate a scorecard for what you should do during an incident? And really, this can carry forward into non-incidents, just during general congestion. And so there's a lot of thought has gone into how to generate scorecards. Now, this scorecard is generated right now out of our prediction. It contains many, many metrics because everybody we talked to had a slightly different metric. And so, in dealing with some of the, like with Aimson, who really works around the world on notions of how you simulate metrics and how you deal with metrics, we've sort of developed this card. And so that we think this is one of the nice outputs of this system. The CMS, the other component of the system, again, is a COT system, and we're currently working with CAPS, Parsons, and Telegra, but there's no reason that other vendors can't implement our interfaces and our workflows. It provides data visualization, basically maps and charts. Workflow allows you to create an incident, determine, look at the response plans for that incident, approve them, disapprove them, etc., work with cameras. And then it's also responsible for actually doing the communication with the traffic control systems that will implement the strategies using signal ramps, signs, messages, etc. So we did it that way because the group that the response plan is approved by them, they need to make sure that it's executed correctly. And then we're also looking at how this really becomes a IEN. With the data hub may function as an IEN as a regional area for a regional area because it can scale fairly easily to that level of data quantity. Okay. So a little bit about our platform and our cloud deployment strategy. We have a single code base which we use, and the differences are in what we deploy and how we configure them. So that just makes it easier to move from one location to another. Again, we were instructed, told, yelled at enough to say this has to work everywhere in California. Don't just build something that's going to work locally one time and move on. So we've been very careful to make this reusable. And so we automate the system deployment. Amazon has told us we're in the top 10% of people who have learned how to use cloud-based automation tools in order to automate deployment within scalable cloud areas. And so that configuration controls networking, security, configuration, the whole overall compute environment. And because we build stuff this way, it means that processes that die can automatically be restarted because no one can build a system where nothing ever goes wrong. You really tell the merit of the system by how it deals with things when things do go wrong. And so we've really tried to turn that into something that is a strength. And so all of this combines to mean that we can do updates and modifications more easily. Caltrans funded us to really build something good. And I can't thank them enough for the vision to do this. It's not always easy for a DOT to find the funds to invest in a truly, game-changing vision, and Caltrans did it. So all of this leads to what really people want, reduction in installation timelines. We can bring up this system in about 4 months with basic components if you're using components that are already in existence. The standards for creation of network descriptions and rules are all there. Existing C2C interfaces can be brought up quite quickly. New C2C interfaces can be developed, in as little as 4 months. It can also take longer depending on many, many factors. This is the technical side, really. What I want to say is allocation of funding and stakeholder agreements operate on a different time frame, and I can't control that, but we can control and help with the technical side of this at this point, and with MOU agreements, for example, that you can use as templates, et cetera, for the other side of it. So, conclusion of my portion, our whole goal here is to reduce stress for everyone on the phone. So relax, calm, and we'll help make ICM a little easier for you, is our goal. So that's that. Turn it back to Nick here.
All right, thank you, Joe. So with all that, we built we have the program. By the way, that we worked with various groups here in our DOT because our culture was not ready for this. And so for the last several years, we've been working with our folks in contracting. We brought in our IT folks almost from the beginning, but I would say really from about the last 3 or 4 years, we've been working very closely with them, and they are really quite excited about the idea of cloud implementation because, you know, that most folks didn't go to school and get a degree in you know, IT or software or whatever and decide they were going to be database managers, right? They want to do things that are cutting edge too, and that's what this is. And so our IT folks have been really great to work with. So once we've got the idea for the data hub, we've got our program kind of going, and we decided you know, obviously you have to show what you can do. And so the corridor for our pilot is the I-210 corridor. On the left, you see it's just a little bit northeast of Los Angeles, the city of Los Angeles. And as Joe mentioned, they've got lots of events, the Rose Bowl, the Rose Parade, lots of football games that happen. There happens to be a racetrack. Santa Anita Racetrack is on the corridor. And the other thing, they've got great parallel arterials. If you look on the right side, that's the corridor. Those arterials that are parallel to the 210, that's what you need to be able to manage the congestion that occurs. And so great arterials. They also have upwards of 600 incidents per month on that corridor. Now they might be as little or as you know, less intrusive as something like a ladder in the roadway, but they also can end up as semi trucks in the middle on your you know, on your transit line. So that's, you know, looking at that. We also had a district, our District 7 is there in Los Angeles. They volunteered to participate in our pilot, and the folks from LA Metro, they're also our partner down there. They are the regional, they are the county transportation agency. They bring their own level of involvement. They bring resources, and you really need a regional or partner to work with because as a state DOT, it's difficult for us to, impossible, if you will, to get resources to local agencies, and so your partner needs to be able to do that. So you need a good relationship with them. And so with that triumvirate of folks, we set off on our pilot in Pasadena. And so where are we with that? Well, as Joe had mentioned, our data hub and C2C interfaces, they're ready and tested. The pilot corridor management system interface to those COTS solutions, those are ready, tested. The decision support system, that test system will be ready in February of 2020. So once we get all of our data in, we can start testing that decision support system to see how it works and make sure that it works properly. The rules engine in the cloud implementation, hardened and put into the cloud, will be in September of this year. So that portion will be available to go. And then after we've tested all that, make sure we've got all the data in and out, make sure all of our partners are ready, make sure that we let the public know what we're doing, of course, have outreach. Then in April of 2021, the plan is to launch the system and actually start managing traffic in the corridor. So we always get asked what are the benefits of ICM, and to be honest, there's not really good data on that at this point because very few folks have actually done real ICM in a highly congested corridor. And we talked to them all. I was part of a domestic scan that FHWA had on ICM, and we visited we visited Minneapolis, and we visited Dallas, and we visited San Diego, and we talked with folks there, and we continue to talk with them to learn from what they've done, and hopefully make our implementation a little bit more efficient, or improve it wherever possible. And so we thank them very much for their involvement. But we did PATH did a simulation a little while ago with some data that we had. And we simulated a incident on the 210, and then we looked at a couple of just basic performance measures, reduction in delay, and for the freeway and Huntington, there was an estimated 13% improvement, or reduction, if you will, in vehicle hours of travel. On the entire corridor, it was about 2%. Our corridor is 12.5 miles long. And the AADTs vary from about 120,000 on one side to over 300,000 on the other end of the corridor. So it's fairly heavily traveled, but there's quite a variation. So in the near future, we hope to do more simulation with that model that Joe had referred to. It's the best we can do. It may not be what everyone wants to see. They want to see what did you get, but until we turn it on, we won't know. But we can model and simulate it, and give them a range of what we expect, and we'll be doing that very, very soon. So not only we built the program, we got our DOT involved, we looked at people, we looked at our needs from a technological standpoint, from equipment standpoint. We also started looking towards the future, of course, because you need to look 10, 15 years out and say, what are we going to need for those? So these are some of the things that we think, that we've been thinking about in terms of what the future needs are going to be, looking at regional management systems, looking at integrated regional mobility or a transportation portal so that everyone can put their data in, the DOT, local agencies, others. With it being open source, we can allow access to certain types of data, probably most of it, but there's still some that maybe not. But that way, you don't have one guy or two people at the DOT and a couple of folks from the UC or your from your local university just determining what can we do with this, right? If you open that data up to everybody, then who knows how many people will go in there, play with it, and determine what they can do with it. So we really want to data share as a main goal of this. Looking at statewide uses for data, performance measurement and business intelligence, those are extremely important nowadays, and so we can do that. Looking towards enhanced regional and statewide traveler information systems, providing data to them. And then, of course, looking at how do we pilot vehicle to infrastructure technologies and strategies. And so with that, we also looked at how, what's next, who's next. And so these are some of the ICM deployments that are currently under development in California. District 12 office, our Caltrans District 12 office in Anaheim has got the Triangle ICM, and I'll tell you a little bit about that in just a minute. We've got one in District 3 in Sacramento, our US 50 corridor ICM. In District 11, San Diego, they're looking at the I-805 South Corridor TSMO plan, which may end up being ICM, depending on what the partners want to do. There's also District 12 in our Los Angeles region. LA Metro has done a regional ITS or ICM plan. So looking at the entire Los Angeles region and determining where the next ICM is going to be and how do they expand what we've done on the 210. And we've also identified 26 additional corridors statewide. as most of you know, if you don't get these types of ideas into your strategic planning documents, it can be a challenge to continue to support them and get them implemented. So we put them in our California Transportation Plan, the CTP, 2040 CTP. We specifically call out, Caltrans does, Connected Corridors and our Connected Corridors program. So the expansion I mentioned in District 12 in our Orange County district, they want to take advantage of what's being built by us and others, and then they want to look at it from a regional perspective rather than just an individual corridor. So if you'll notice here, it's a little messy on a slide, but there's a triangle area in there that includes the city of Anaheim, and Anaheim has major event centers, right? They've got Disneyland, they've got the pond where the Mighty Ducks play. They've got Cal State Fullerton is up on the northwest area. They've got a lot of different folks going to Anaheim, and they need to manage not just the freeways, which we already do, but those local arterials to get people to and from the happiest place on earth. So what does expansion mean? Well, in this case, it means new C2C interfaces, not just the ones that Joe mentioned before, but potentially SWIRI for ATMS, Econolite, and Intolite. Those are the signal software programs that they use in that area. And so those are the new C2C interfaces that we're going to add in District 12. And then also expansion to connected vehicles in our District 12 area with arterial RSU and freeway RSU applications to ingest that big data that Joe talked about and make sure that we can manage it, get it back out to the public and folks that are out there, and do an even better job of managing those arterials and the freeway system. Well, if you put together a statewide program with an excellent pilot that works, you want to look towards how do you do this over and over. So we've identified new corridors. Well, if you have a corridor that's using a regional data hub and you have multiple corridors all over your state, then you need to think about, okay, can we use business intelligence tools? Can we use different types of data interface structures to look at system performance across the state on every corridor that has an ICM, and then look at it for different things about operational analytics, corridor performance, different metrics, cost, revenue, etc. That way you can plan everything for the whole state with a very standardized approach. Now, we were recently at a presentation, and FHWA was there, and they have their 10 attributes of a successful ICM site. This is a 2-page document you can download. It's very informational, and I provided the website here, and the folks you talk to, if you're interested in that kind of stuff, good guys, all of them. And I want to, on the back of that sheet, it has your 10 different things, and many of these are focused on institutional change, public engagement, things like that. But number 7 talks about a centralized data hub. And that's not something that is easy to do or quick to do, and it doesn't rely on just grunt effort. You got to change your culture. You really need to have that, and that's what we've created so that we can share that data. So we decided to go to open source from the very beginning, and we're thinking about, or we are trying to get interest, or seeing the interest, gauging the interest for a pooled fund. Now, why would you want to do that? From my standpoint, I'm looking at it as ease of administration. I don't have complex licensing. I don't have sole source contractors or vendor-specific solutions. I don't have to deal with procurement contracts all the time, and I don't need fees for software updates. A lot of it is cost-related. The benefits are there's lower upfront costs, etc. More agencies adopt it. The solution becomes cheaper every time that's adopted. And then it also allows new ideas and functions to be tested and implemented at a lower cost. And then finally, I think greater access to innovation, as I spoke about before. If you have a data lake, if you will, or a data transfer spot. It allows folks to do, leverage the community of folks who are involved to look at, what are the new things that we can do? How can we innovate? And then finally, standardization of those open source interfaces and reference implementations that others can use, extremely important, and that will help us all in the end. And that's my presentation. That's our presentation. Thank you all for being here, and we appreciate it.
Thank you, Nick. That was great. A couple of things in the chat box for everybody who's on the line. The presentation will be made available. You'll receive an email. It's also going to be up on our YouTube channel, or the audio is being recorded. If you look on the box, there's a resource box here right now where you can download both of those documents that Nick just referenced, the 10 attributes of a successful ICM and what is integrated corridor management. Those will also be included in the email that you receive at the end when we get this up and running on the web for us. We do have any remaining questions. I do believe Jim Hunt had one in the chat box. That he asked Nick or Joe what baseline performance information is being captured to evaluate and validate the 210 deployment. Can either of you answer to that?
I can, and I would say any of the data that comes in, which is all of the detection data, all of the signal data, all of the detection data on the arterials, all of that comes in we can use to determine performance. So delay, reliability, incident reduction numbers, because we already have incidents, of course. We are looking at how we can determine the impact on all types of incidents, the safety improvements that are out there. There are a lot, vehicle miles traveled, which is something here in California that we're looking at very closely. That's something that we're going to be able to estimate. So, Joe, can you think of any besides those, a lot of the system ones?
The scorecard was interesting for us because that's where everybody talked about the things they were interested in. I mean, people were interested in queue reduction, for example, on and off ramp measurement. I mean, many areas we're going to be looking at in this. Which one we finally decide to use in publications, we're not sure yet, but and also we'll probably be using probe data to get additional information, Bluetooth data, travel time. So we're bringing in a lot of different data types, and we're looking at a lot of different possible metrics to really understand what's best in measuring success.
Right, and we're also, in addition to throughput, things like that, mm-hmm. but there are core ones that we all have to kind of adhere to: delay, reliability, certain ones like that, safety. But I'm kind of interested in the new ones that we didn't really think about, that because we can use, our technology and our data hub, we can analyze it in ways that we haven't before, and maybe we can find some new performance metrics that'll kind of help us to understand the impact. So, basically it's all the old ones and some new ones.
Super. Hey guys, before we get off the phone here, we do have some polling questions that we'd like to ask. Joanna, can I turn this over to you to see if you can get this up on the screen for the folks that are on the line before we have to go? If you wouldn't mind, what we'd like to do is say that we're trying to get some background on, has your agency completed any ICM? And so the options there are currently you're implementing, you're thinking about implementing, not currently planning on implementing, or no vote. So this would be great for us to get a little bit of sense of where you guys on the phone are at. After this has been a great presentation on both sides with the AI and the ICM. But trying to get an idea of where you all are sitting with this would be great. So we'll give them a chance to vote, guys, and then come back to you if that's okay. While they're voting, though, I do have a question for Nick and Joe. How difficult? I saw a couple comments about the challenges of public sector web services, getting in the cloud data. Storage. How difficult was that with Caltrans to get that idea moving forward? Because I know that that is a challenge with some public sectors, is that going to the cloud, which eventually you'll have to go to the cloud.
Yeah,
do you have any challenges with that?
that's an excellent question, and I would say we have what 5-10 years ago we were told no, right? Basically, don't think about it. But we thought about it. We decided to do it, and the key, I think, was bringing our IT folks in, from as early on as possible. We did things like we worked with Amazon for training for our IT folks. We took them to the university so that they would understand what our data hub is doing and how it worked. We work very closely with our IT folks to get them excited because this is exciting for them too. And so the other thing I think is the idea of scalability and replicability. I mean, if you try to do this on your own servers, it's going to take you forever, right? Just to buy the servers that are going to be out of date by the time you get them. And so the idea that we could stay on top of this by using Amazon cloud services, and then the tools that they have there that we haven't even really started to take a look at that can help us to analyze, the data that's there and how we're using it. And when you're talking about a potential of 25 corridors across the state that you're going to be responsible for, buying all of that infrastructure is just not compelling. And it's not cost effective either. And so that was kind of, if you go small, you can think small. If you go big, you got to think big.
I would add that we get this question a lot about, working with IT, for example, on new ideas. And we made sure we brought in software engineers to speak with IT personnel and not traffic engineers. And that made a huge difference in the ability to communicate rapidly back and forth on what our plans were, what the issues were, how to address security issues, questions that IT often asks that traffic engineers currently have kind of a hard time answering. So I think it's very important as you pursue this to just make sure you have the right people in the room for these conversations. They really move, as Nick said earlier, everybody in IT wants to go to the cloud, sooner or later. So, but they're a little frightened of it. So if you can help with that by bringing the right people in, it's good.
And we work to standardize that interface. Just real quick, to work to standardize the interface between the cloud and our TMC. Very important.
Yeah, I remember when I put my ATMS system in the cloud back in 2013. Everybody thought I was crazy back then, but it's all been good. Guys on the phone or on the web, we have one more question. Is your agency interested in participating in open source? I put it up while Joe and Nick were talking, but if you want to weigh in on it, the three options were: my agency is interested in participating, my agency is not yet interested, or I'm not sure, but I'd like some more information. So if you could give a shout and your thoughts on that, we could then compile that information. And as you know, this stuff will go out. This goes back out to you. The polling results, any of the Q&A that comes into the chat box here, as well as a link to the slides, as well as the audio. Nick and Joe, one last question before we got to go here. But Jivanjo asked if you guys have IT staff for your agency on your agency payroll. That's the last question that's in the chat box. So.
Yeah.
Nick, could you speak to that?
We have a division of IT, and a number of them, we absolutely do. Yep.
All righty. With that, I believe that we're done with our polling questions, and we are out of time.